So this idea that we just discovered is what's known as an arithmetic sequence. So there's a sequence of numbers that's increasing using arithmetic. So if I look at this sequence of numbers, we have 3, 7, 11, and 15. So I notice here that I start at the number 3. And then every time I'm looking, I either add or I can subtract as well at the same term. So to go from 3 to 7 or 7 to 11, I just add 4. So right now when I'm adding 4, that is what's called the common difference. So what you're counting by. So now if I look at a recursive rule, I just have to say, well, what number do I start at? So I'm going to write it like this. A sub 1. This is the first term in the sequence, and then that equals 3. Sometimes sequences start at a sub 0, sometimes they start at a sub 1. This does not say at like 0 minutes, so we start at a sub 1. So a sub 1 equals 3, and then we write a recursive rule. So a sub n, if I want the nth term, so if I start at like the 15th term, what I do is I take a sub n minus 1, the term before it, and I add 4. So for example, this would just say, if I start at 3, so if I plug in 3 as my starting term, then I would go 3 plus 4, and then that gives me out 7. And then I can start with 7 and plug that in as a sub n minus 1 and see what the next term is. So if I want the next term, I go 7 plus 4, and then that gives me 11. This is just a formula for saying that. So that's a recursive formula. You also have the explicit formula. So if I'm looking at a table, and if I made an XY table, we would say, well, when X is 1, Y is 3. When X is 2, Y is 7. And then 3 and 11 and 4 and 15. So if I look here, I can see the rate of change is 4. So we could say y is equal to 4x. And that's like y equals mx plus b. Remember, b is our y-intercept, which is on a table is when x equals 0. So if I plug in 0 there, I could work backwards and say, well, 3 minus 4 is negative 1. So one of my explicit formulas is y equals 4x minus 1. Some people will actually adjust that. So what you can do is you could also say, I could start at 3. So you could say y is equal to 3 plus 4 times, and then instead of multiplying by x, you can multiply by x minus 1. So if you notice here, if I work that out and I substituted 3 in, 4 times 3 is 12, minus 1 is 11. And if I substituted 3 in here, I'd have 3 minus 1 is 2, 4 times 2 is 8, plus 3 also is 11. So both of these say the same thing. In fact, there's 2 formulas that you could use for the explicit formula. You could say, for a sequence, y equals a sub 0. I started kind of like at the 0th term. plus d, the common difference, times n. Let me label those. Or you could also, well, what if I don't start at the 0th term? What if I start at the 1st term? Well, your formula, the other formula, you could say y equals a sub 1, starting at the 1st term, plus d times, in parentheses, n minus 1.